Okay, let's check problem 2. We'll have two series. As I mentioned in the second email, this 3 should be equal to 1. Okay, let's check this one. This series can have positive terms and negative terms, depends on the value of n. And we actually can prove that this series is convergent. But to prove this is convergent, we need a result which says the absolute convergent series converges. So to prove that this series is convergent, we can try to take the absolute value of the numerator and the denominator. Well, the denominator is already positive, so you don't have to worry about it. So basically take the absolute value of the numerator and then check if the series with absolute value is convergent. If that is convergent, that means this original series is absolute convergent. And if it's absolutely convergent, then it must be convergent. Okay, it will be helpful for you to write something like this next to the question. So in case you made a mistake in your calculation, you can get partial credits for writing something like this. Okay, so let's check if it is absolutely convergent by taking the absolute value of sine n. The convergence of this series can be proved by showing by the comparison theorem or comparison test, because this is no more than 1 over n to 3 over 2 plus 1. That is because the absolute value of n is always no more than 1. Here, we can try to make the denominator in this fraction smaller. Now we know this series is convergent because it's a p-series and the p is equal to negative 3 over 2, which is less than negative 1. So this is convergent, and that implies the convergence of this series. Remember, this one is a series with non-negative terms. So according to comparison test, we know that this is convergent. And this implies the convergence of the original series. So we're done. For the second question, you see that this is an alternative series. That means the sign of these terms are positive, negative, positive, negative. It's alternating all the time. Okay, so we can use the alternative test to prove that the series is convergent. How to do that? First, claim that the series is an alternative series. This should be obvious for you, right? The terms in the series is positive, negative all the time. Secondly, you have to show that the absolute value of the general term is decreasing. Which is the same as 1 over n to 1/2 plus 1. And it's obviously decreasing, okay? Last, you need to show that the limit of the absolute value of the general term, which is here, is equal to 0. That's also obvious. So once you check the three conditions, first it is alternating, and secondly the absolute value of the general term decreases. Third, the limit of the absolute value of the general term is equal to 0. Once you check the three conditions, you can say that the original series is convergent. And actually it is conditionally convergent because the sum of those terms diverges.